Hello, today we're going to be doing 5.2a, which is writing equations of polynomial functions. We're going to be finding zeros of polynomial functions, and we're going to write an equation with given zeros for that function. So the things that we talked about yesterday was the fundamental theorem of algebra, where if a polynomial has degree of n, then the polynomial has n number of roots. Roots are another word for solutions, zeros, x-intercepts. So if you look at this first polynomial, it is f of x equals x cubed minus 2x minus 1. Our highest degree is 3. That means we have 3 roots for the first function. G of x equals x to the fourth plus 2x squared minus 3x plus 4. Again, the only thing we care about is the term x to the fourth because that is our highest degree. So that tells us this has 4 roots. So we're just looking for the highest degree there. Now we have to think back to imaginary and complex conjugates. They must always occur in pairs. So if we have 2 plus 3i as a solution to the polynomial function, what must the other solution be? Well, if it's 2 plus 3i, then the opposite of that we think of is just 2 minus 3i. That's its partner. We only change the sign in between 2 and 3i. If 5i is a solution to the polynomial function, what must another solution be? Again, we just changed the sign in front of the 5i, so it would be minus 5i. Now we're going to identify the factors of a polynomial function that has these given zeros. The factors are going to look like this form here. F of x equals a x minus the root, x minus the root. So we're going to put it in that form of x minus our root. We talked about this when we were discussing x minus p, x minus q when we talked about quadratics. So if 7 is one of our roots, it's going to be x minus 7. It's basically the opposite sign. And then if we have 3, that would be x minus 3. And then our last 0 is negative 4. If we plug in a negative, it's going to be x minus a negative 4, which ultimately becomes x plus 4. So it's again the opposite sign of negative 4. Now we go over here to the second set. The first one is going to be x minus 2. Then it's going to be x minus 3i. And then x plus 3i. These next few get a little bit trickier. So we have 8, 3 minus I, and 3 plus I. Remember, it is x minus our root. So the first one is easy. It's x minus 8. But the second one, for 3 minus I, we're going to put x minus, and then we're going to put 3 minus I in parentheses. We have to be sure to distribute the negative sign to the 3 and the negative I. So it's going to become x minus 3, and then plus, let me backtrack here. First one was x minus 8, then we had x minus 3 minus I, and that is going to become x minus 3 plus I. So that's for this root right here. Then we have to do x minus 3 plus I, which is going to become x minus 3 minus I. And there are our 3 roots. Looking at our last set here, it would just be x minus 5, x plus 3, x minus 2i, and then x plus 2i. So nothing too challenging right there. Moving on to the next part, if you need to pause at this point. Okay, now we want to write a polynomial function of least degree with a leading coefficient of 1 and the following zeros, 1, negative 4, and positive 5. So it's going to be f of x. Now notice it says leading coefficient of 1, so that's going to represent our a value, and of least degree just means the smallest degree possible, which in this case, if we have 3 zeros, that means it has to be a cubic function. So it's going to be f of x equals, we can put the 1 in place of a, and then it's going to be x minus our first root, which is 1, x minus our second root, negative 4 makes it plus 4. Lastly, it's going to be x minus 5. And there we go, there's our answer. The next problem says write a polynomial function of least degree that has real coefficients, a leading coefficient of 1, and negative 2 plus I, and negative 2 minus I as zeros. So the leading coefficient is 1. 1 is a 0, negative 2 plus I, and negative 2 minus I are 3 zeros, which means it's going to be a cubic function when we're all done. So this is going to be f of x equals, the first one is going to be 1 in place of our a, then it's going to be x minus 1, x minus parenthesis negative 2 plus I, we have to be careful for these zeros, and then x minus negative 2 minus I in parentheses. Now let's simplify this by distributing our negative inside of the parentheses. So it's going to be f of x equals, and we don't need to include the 1 since that's representing a. So it'll be x minus 1, x plus 2, and then minus I. Next, we are going to have to distribute here and here. It's going to be x plus 2 plus I. Okay, so we're going to leave this in factored form. When I come back, we will talk about distributing this, but for the sake of today, we're just going to leave it in the factored form, and then when I come back, we'll talk about how we put it into standard form. So this is going to be our answer for right now. All right, continuing on. We want to write a polynomial function in standard form of least degree with a leading coefficient of 1 and the following zeros, 2, 3, and negative 3i. Now we have to be careful with this problem because 2 and 3 are nice zeros, but negative 3i has to come with a partner. So the partner to negative 3i is plus 3i. So in actuality, we have 4 zeros on this problem rather than just the original 3. So it's going to be y equals 1, x minus 2, x minus 3, x plus 3i, and then x minus 3i. Now this one tells us to write in standard form, and this one's a lot easier to put in standard form. We just need to FOIL. So let's take these two at a time. So the first ones we're going to multiply are x minus 2 and x minus 3. That will give us x squared minus 2x minus 3x plus 6. And we can actually multiply the ones on the right as well. That's a difference of squares, which is what we want because we want to get rid of our imaginary numbers here. So x times x is x squared. X times negative 3i is negative 3ix, and then plus 3ix, and then here we end up with minus 9i squared, which is great because we know I squared equals negative 1. And then our middle terms are going to cancel out here, since negative 3ix plus positive 3ix is going to be 0. So let's simplify this first parenthesis on the left. We get x squared. Let me just erase that really quick. It's going to be x squared minus 5x plus 6. And then on the right, we're going to end up with x squared. Negative 9 times I squared is going to become plus 9 because of the I squared. And now it turns into a problem that we're more familiar with, where we just need to distribute each term in the right parenthesis to each term in the left parenthesis. So we get y equals x to the fourth minus 5x cubed plus 6x squared. Now we distribute the 9. We get plus 9x squared minus 45x plus 54. Let's combine our like terms and get our final answer. Y equals x to the fourth. We only have a minus 5x cubed. And then we can combine 6x squared and 9x squared to give us 15x squared minus 45x plus 54. And here is our final answer right here. And this is a quartic polynomial, which is what we wanted because we said originally there was 4 zeros, so we wanted to end with a fourth degree polynomial. Our last one here says, write a polynomial function in standard form of least degree with a leading coefficient of 1 and the following zeros, 4i and negative 3i. So with both of these, we know that they have to come in pairs. So it's 4i and minus 4i, negative 3i, and positive 3i. Now we're going to have y, or f of x. Our leading coefficient is 1, so it's x plus 4i, x minus 4i, x plus 3i, and x minus 3i. Again, we are just going to multiply the two binomials that go together, since these are going to be differences of squares. So the first two are going to give us x squared minus 16i squared. The second set is going to give us x squared minus 9i squared. And we know that I squared equals negative 1, so it's going to end up being x squared plus 16 times x squared plus 9. Now let's just FOIL these two out. X squared times x squared is x to the fourth. X squared times 9 is 9x squared. 16 times x squared is 16x squared. And 16 times 9, don't know this off the top of my head, let me look here, is going to be 16 times 9, 160 minus 16, 144. So we get y equals x to the fourth plus 9x squared plus 144. Oop, messed up there. We need to add the 9x squared and the 16x squared, and that will give us 25x squared plus 144. And that should be it. That's our last example. Okay, so try your best with these problems. You'll get the homework now. If you get stuck, do as much as you can. Take a look at the key if you need to, but I will be willing to answer questions and give you some extra time when we come back on Monday. Thanks.